Hey everyone, this is Jahangir, Maths Coach for British Curriculum. You are most welcome to October-November 2022 Further Pure Mathematics Paper 1 video solution. Thanks for subscribing this channel, and if you have not subscribed yet, then please subscribe now, like and share for my motivation and good maths content in future. I have already solved February-March 2023 other math papers whose links are provided in the description below. You can watch the video and download unsolved paper which you can practice. Now let's start our video solution. As you can see here, this is paper 1 for the Pure Mathematics 1. And this is October-November 2022. This is paper code 9231. This is a further Pure Mathematics. This is for 2 hours and it is for 75 marks. So question number 1. Question 1 says this is a cubic equation x cubed plus bx squared plus d equals 0 has roots alpha, beta and gamma, where alpha equals beta and d equals 0. So here we know that if we have cubic equation like this, ax cubed plus bx squared plus cx plus d equals 0, and suppose you have roots alpha, beta and gamma, then you can write sum of roots alpha plus beta plus gamma equals minus of coefficient of x squared, which is b, over coefficient of x cubed, which is a. Now a sum of product of roots taking 2 at a time, it means alpha beta plus beta gamma plus gamma alpha. That is x coefficient, which is c over a, like x cubed coefficient, and the product of roots alpha, beta and gamma, which is constant, but outside you have to apply minus d over a. So how you can remember this, like when you have to apply plus, when you have to apply minus. You should start like that. Just write plus sign, minus sign, plus sign and minus sign. So if you need to find sum of roots, then you can write minus b over a, then product of roots plus c over, sum of product of roots taking 2 at a time, it means alpha beta, beta gamma, gamma alpha, then plus c over a, and the product of roots, which is alpha beta gamma minus d over a, like that. So it is easier for you to remember. Now here you can check, we need x cube, x square, x and constant, but here x cube available, x square available, then x is not available. So x I have written 0x, right? And the constant part d is available. Okay, now here we have 1x cube, bx square, 0x plus d, then sum of roots, like this is plus minus, so minus b over 1, and the sum of product of roots taking 2 at a time, it means alpha beta, beta gamma, gamma alpha, which is 0 over 1, and product of roots alpha, beta and gamma, that's minus d over 1. So alpha plus beta plus gamma, that's equals minus b. And here we have information alpha equals beta over here, and d should not be 0, which we will use later. So here what I'm gonna do, alpha is alpha, beta is alpha, and gamma plus gamma equals minus b. So alpha is alpha plus alpha, that's 2 alpha, which I took to right side. So gamma equals minus b minus 2 alpha. Now here beta is alpha, so alpha times alpha, now alpha times gamma, then gamma alpha equals 0. So alpha square and 2 gamma alpha equals 0, which I got this. Now product of roots alpha, beta and gamma, that's minus d. So alpha is alpha, beta is alpha, then gamma, alpha square gamma minus d, gamma is minus d over alpha square, which I have substituted over here to get alpha square plus 2 alpha, and instead of gamma I have written minus d over alpha square. Now 1 alpha I can cancel, so alpha square minus 2d over alpha. And if you multiply alpha here and alpha here, then alpha times alpha, this is alpha cube, and alpha again cancel, so minus 2d equals 0. So here you can check alpha equals 2d, then alpha is 2d to the power 1 over 3. Okay, fine. Now I got alpha equals 2d to the power 1 over 3, or you can say alpha cube equals 2d. Okay, fine. Now here, okay, I need to erase this, it doesn't look good. Okay, now you can check alpha, beta and gamma. These are roots of this equation. So alpha will satisfy this cubic equation, right? So this will be alpha cube plus b alpha square plus d equals 0. So same thing I have written over here. Alpha cube b alpha square plus d equals 0. Now alpha cube, already we have 2d, so I just substituted 2d. Now b alpha square plus, I did not substitute alpha over here, I will substitute later. So now b alpha square plus d equals 0, then 2d plus d, that's 3d equals minus b alpha square. Then I did cube both sides. So this is 3d whole cube and minus b alpha square whole cube. So this is 27d cube, and this will be minus b whole cube is minus b cube, and alpha to the power alpha squared to the power 3. So we can write alpha squared to the power 3. We can write alpha to the power 3 times 2, or again we can write alpha cube whole square, right? So I'm gonna write over here alpha cube whole square, and now this became 27d cube, and this is minus b cube, and alpha cube whole square. Alpha cube was 2d, so it is 2d whole square. So this is 20. Now come to this step, 27d cube minus b whole cube and 2d 2d whole square, which is 4d square. Now 27d cube, and this is basically minus 4b cube d square, right? So this is, so this is d cube and this is d square. So d cube over d square is d only. So 27d and minus 4b cube I got here. Now shift left side, 27d plus 4b cube equals 0. So we have proved this, 4b cube plus 27d equals 0. Now given that 2 alpha square plus gamma square equals 3b, find the values of b and d. Now we know that alpha plus beta plus gamma whole square, if you expand, then you will get alpha square plus beta square plus gamma square plus 2 times alpha beta plus beta gamma plus gamma alpha. Now alpha plus beta plus gamma whole square equals alpha square plus beta square plus gamma square plus twice of this alpha beta beta gamma gamma alpha, which was 0 in the beginning. Over here you can check, so that's 0. So an alpha plus beta plus gamma, sum of roots was minus b, so minus b whole square alpha square beta and here beta square is again alpha square plus gamma square. So what I got b square equals 2 alpha square and 2 alpha square plus gamma square over here, right? Then I need to get this value 2 alpha square plus gamma square from somewhere. So how can I get that? 2 alpha square plus gamma square equals 3b I have written, right? So it is given in the question, 2 alpha square plus gamma square is 3b. So just write 3b. So b square equals 3b, take left side, b square minus 3b equals 0. Factorize b bracket b minus 3 0. B can be 0, b can be 3. So why we need to reject b as 0? So if you put b equals 0 in this 4b cube plus 27d equals 0. If you put b equals 0, so 0 plus 27d equals 0. So d will be 0, right? And in the beginning, if you check the question, then it is clearly mentioned over here, d cannot be 0. So that's why b cannot be 0. So b can be 3, yes. So we have to accept b as 3. Now we know that 4b cube plus 27d equals 0. Just put b equals 3. Calculate, you will get d equals minus 4. Now move to the next question, that is proved by mathematical induction. for all positive integers, and this is divisible by 48, or you can say this should be multiple of 48. So here there are 3 steps. So step number 1, we have to verify for n equals 1. So just put n equals 1 in this expression. So 7 to the power 2 times 1 plus 97 to the power 1 minus 50, which you calculate, that's 96. And if you observe, this 96 is divisible by 48. So step number 1 is valid. So generally step 1 is always valid whenever the question is mathematical induction. Now second step is the assumption. So we have to assume for n equals k is true. Like just put n equals k and assume that it is true, like it is divisible by 48. So 7 to the power 2k, 97 to the power k minus 50 equals divisible by 48. So 48 multiple, right? 48 times lambda. So here 48 times lambda, you need to understand this is multiple of 48 times something, or you can say this will be divisible by 48. That's why I've written as 48 times lambda. Now we need to check for n equals k plus 1. We will use second, you have to use second step for proving step number 3. So now check for n equals k plus 1. So just put n equals k plus 1, then 2, like here n is k plus 1. So 7 to the power 2 bracket k plus 1, 97 to the power k plus 1 minus 50, which you can check. Now break 7 to the power 2k times 7 square. Now 97 to the power k times 97 minus 50. So this is 49, this is 97, this is minus 50. Now this is 49, 7 to the power 2k, 97 times 97 to the power k. Yeah, minus 50 I have replaced by something. Yeah, from here. I told you in step 3, step 2 we have to use. So what you can write minus 50 as, you can write minus 50 equals 48 lambda minus 7 to the power 2k minus 97 to the power k. So this minus this I have substituted as minus 50, which you can check here, right? 48 lambda minus 7 to the power 2k minus 97 to the power k. Now important stuff is here, this is 49 times 7 to the power 2k, and here minus 1 times 97 to the power 2k. So 49 minus 1, that's 48. That's how I got this result. This is 97 times 97 to the power k, and this is minus 1 times 97 to the power k. So 97 minus 1, that is 96. So 96 times 97 to the power k, and that's 48 lambda. So now if you observe carefully, then this is 48, this is 96, this is 48. So 48 you can take common. Inside you will get 7 to the power 2k, 97 twice of 97 to the power k plus lambda. So what I got, 48 outside, and I got some number here. In terms of k doesn't matter, but I got 48 outside. It means this is multiple of 48. It means this can be divided by 48, right? Hence we proved. Yeah, factor of 48, it means we have proved that. Now by considering 2r plus 1 whole cube minus 2r minus 1 whole cube, use the method of difference to prove that r equals. Okay, so we have to use this. This is a cube minus b cube. So either you can expand 2r plus 1 whole cube and 2r minus 1 whole cube and subtract. You will get this result. Or I used a cube minus b cube, which is a minus b times a square plus ab plus b square. So this is a cube minus b cube, a minus b, a square plus ab plus b square. Just I calculated, you can observe this, you will get 24r square plus 2. You can pause the video and you can understand all the steps. 24r square plus 2 I got. Now this expression can be written as 24r square plus 2. Okay, that's fine. Now apply sigma from 1 to n, both sides, like here as well as here. So 2r plus 1 whole cube minus 2r minus 1 whole cube, it is cube not square. 2r minus 1 whole cube equals sigma r equals 1 to 24r square plus 2. Now when you put r equals 1 here, then this is 2 times 1 plus 1, that's 3 whole cube, and 2 times 1 minus 1, that's 1 whole cube. So you will get 3 cube minus 1 cube. When you put r equals 2, you will get 5 cube minus 3 cube. When you put r equals 3, you will get 7 cube minus 5 cube. Similarly, this procedure will go on, and finally you have to put n. So this is 2n plus 1 whole cube minus this. Okay, that's great. Now here if you put r equals 1, then 24 1 square, 24 2 square, 24 3 square, just you can take 24 common, then you will get 1 square, 2 square to n square. And for r equals 1, then it is 2, r equals 2, then it is 2. So you have to add n times, so 2n. Now here we need to do very important stuff. What is that? Cancellation. See, this first term is cancelled by last term. If we compare these two, now here this 5 cube has been cancelled by last. It means last term will be cancelled. You will be left with 2n plus 1 whole cube and minus 1 whole cube. So here you can check minus 1 whole cube and 2n plus 1 whole cube, and this is 24, and this part you can write in sigma form. So 24 sigma r square 1 to n, and 2n is outside. So minus 1 and 2n plus 1 whole cube, just expand. 2n plus 1 either you can write 3 times, or you can apply a plus b whole cube formula. So when you expand, you will get this result. And then take 2n to left side. So this is minus 2n. Okay. Now just calculate carefully. Simplify. You will get 8n cube plus 12n square plus 4n, and then 24 sigma r square, r equals 1 to n, which is here. Now divide by 24. Okay, like 4 over 24. 24 got cancelled. 4n over 24 here, and 2n square 3n plus 1. This is n over 6, definitely 4 over 24 is 1 over 6, and 2n square plus 3n plus 1, just you can factorize. Finally you will get this result. So sigma r square, r equals 1 to n, 1 over 6, n times n plus 1, 2n plus 1, 6. Okay, now come to the next question, that is Sn, which is 1 square 3 times. So in this kind of question we need to understand pattern. I need to find Sn, S2n. Okay, no problem. So S2n, I mean even numbers. Okay, S2n is even number. So let us understand when like up S2n, like up to 4. Okay, n is 2, then S2n is S4. So just check up to 4 terms. 1 here, 1 2 3 4. Okay, here. Okay, so what is happening over here? If your S4, if it is S4, then last is 4 square, then you are getting 1 square, 2 square, 3 square, and 4 square, but it is in different way. How? Let us understand again. 1 square alone, 3 square alone, but 3 times 2 square and 3 times 4 square. Okay, if it is 4, then last will be 4. We understand. Okay, so if it is S2n, it means last will be something times, like this is 3 and this is 4. So 2n minus 1 times 2n to the power 2, right? So that I will explain, you don't worry about it. Okay, so now just write some more terms here. S2n, I have written 1 square, then 3 square, then 5 square. So 1 square, 3 square, 5 square. And I told you if it is 4, then before is 3. So last is suppose 2n, then before is 2n minus 1. So that will be 2n minus 1 whole square. So till this you will get. Now for this part you will get 3 times 2 square, 3 times 4 square, 3 times 6 square, 3 times 8 square, and finally 3 times 2n square. So if you take 3 common, okay, here 3 times 2, 3 times 4, 3 times 6, 3 times 2n whole square. So this is 1 square, 3 square, 5 square, 2n minus 1 whole square. You can take 3 common. So 2 square, 4 square, 2n whole square. So 1, 3, 5 odd numbers. So you can write 2r minus 1 whole square, 1 to n. And here you can take, this is 2 square. This 4 can be written as 2 square. Or you can say, in this way you can write this 2 square, this 4 can be written as 2 times 2 square, then next is 6, so 2 times 3 square, then 2 times n square, right? So 2 square will be common from all, so you can take 3 outside, and from here 2 square outside, so 1 square, 2 square till n square you are left with. Now s to n, which is sigma of 2r minus 1 whole square, just expand 2r minus 1 whole square, which is 4r square minus 4r plus 1. This is 12, and this is sigma r square, r equals 1 to n. Now this is, just take inside, which is 4r square sigma r equals 1 to n, and this is 12r square sigma r equals 1 to n. So 12 plus 4 is 16 r square r equals 1 to n minus 4 sigma r, and then sigma 1 r equals 1 to n. Now 16 is 16, but we know that r square sigma r square r equals 1 to n is n into n plus 1 to n plus 1 over 6 minus 4. Sigma r equals 1 to n, we know that n into n plus 1 over 2, or you can use formula, right? Here formulas are not given. This is further mathematics. Maybe formula sheet will be given to you. If it is not given, then you should memorize all these formulas. N into n plus 1 divided by 2, and sigma 1 r equals 1 to n, it is n. Now step by step I have calculated, I have shown all the necessary steps, how to do common, and finally you can pause the video and you can go over with the steps, these steps. This is your work. Now I state the value of limit s to n over n cube and tends to infinity. Okay, we have to divide by n cube. Okay, so divide by n cube. So this and over n cube, right? When you divide n cube, then 3n cube will be in denominator. So what you can write, 1 n over n cube. So here it is n square only. Okay, it is n square now. So give 1n to denominator of 2n plus 1, and give 1n to denominator of 8n plus 1. So this is 2n plus 1 over n, and this is 8n plus over n. N into n, it is still n squared. That's fine. Now 2n over n, which is 2, and 1 over n here. 8n over n, which is 8 plus 5 over n. Now apply n tends to infinity. When you apply infinity, then 1 over 3, this is 2. 1 over infinity is 0. 8, 5 over infinity is still 0. So 8 times 2, 16, 16 over 3 finally. Now question 4, that says the plane contains lines. Okay, we have these 2 lines. So we need to find equation of the plane. So that's very simple. You know, for the plane we need 1 point and 1 perpendicular vector, or that is called normal. So for this line you can check, we have 1 point here. For this line I have considered, okay, for this line, this is 1 point, 3i minus 2j plus k, which you can check here, and this is 3i plus 2j minus k. 1 point is here, and the parallel vector is this, which you can check, and parallel vector is this, direction vector is this. Okay, so if you take cross of these 2 vectors, then you will get perpendicular vector to the plane. So just take cross product. So 3i plus 2j minus k and minus i plus 2j plus k. You know, I, j, k, we have to write the coefficients here, and I will be here, and then this cross multiplication, 2 times 1, which is 2, and then minus of 2 times minus 1, which is plus 2. Then this j will be written as minus j, and then 3 times 1 and minus 1 times minus 1 with negative sign. So you will get 3 minus 1. Then write k, and then you have to write 3 times 2 and minus of minus 1 times 2. So you got n, which is 4i minus 2j plus 8k. Now equation of plane is r minus a dot n, or you can say r dot n equals a dot n. So r dot n, r is xi plus yj plus zk, and n already we found 4i minus 2j plus 8k, and a is one of the points. Either you can say this point or this point, no problem, any point we have to consider. I have considered 4i plus 4j plus 2k. So sorry, I have considered 3i minus 2j, 3i minus 2j plus k. This is a, and n is 4i minus 2j plus 8k. So xi dot 4i, which is 4x, yj minus 2j, which is minus 2y, then similarly 8z, 3 times 4, that is 12, minus 2 times minus 2, which is plus 4, 1 times 8, which is 8. So 4x minus 2y plus 8z is 24. Divide by 2, you will get 2x minus y plus 4z equals 12. The line L passes through the point P with position vector 2i plus 3j plus k and is parallel to the vector j plus k. Okay, the line L passes through the point P. Okay, this is the point P, 2i plus 3j plus k. L is passing through this point. This is your L, and it's parallel to j plus k. Find the acute angle between line L and the plane. So this is theta. Okay, and we know that this is my normal perpendicular vector. So angle between line and perpendicular is 90 minus theta then. Okay, and this is parallel vector. So angle between parallel vector and the normal vector is this, but these two are parallel. So this is 90 minus theta, this should be also 90 minus theta. So now one vector is this j plus k, 90 minus j plus k, and another vector is 2i minus j plus 4k, which we got here. Okay, this is 4i minus 2j plus 8k, which can be written as 2i minus j plus 4k. Okay, because 2 is the common for everyone. So 2i minus j plus 4k you can write. So 2i minus j plus 4k. Now angle between these two vectors, we know that cos of angle between them. So cos of 90 minus theta. Now dot product of these two vectors over magnitudes. So 2i minus j plus 4k dot j plus k over 2i minus j plus 4k mod, like magnitude, and times j plus k magnitude. There is no I here, so 2i, and there is no I here, so that is 0, but minus j dot j, that is minus 1, and 4 k dot k, that's 4. And if you apply magnitude here, then root of 2 square minus 1 square 4 square, which is 21, and root of 1 square and 1 square, which is root 2. Calculate 3 over root 42 you will get. But cos of 90 minus theta is sine theta. So sine theta is 3 over root 42. So theta is sine inverse 3 over root 42, which is 27.6. Find the position vector of foot of perpendicular from P. Okay, so this is P, and this is your plane. Just draw perpendicular, you will get some point M. So we can find equation of line passing through P, and it's perpendicular, right? So it is parallel to the normal vector. So normal vector is 2i minus j plus 4k, which we found here. 2i minus j plus 4k, right? Now we can find equation of this line because the line is passing through the point P, and as well as parallel vector is given. So equation of line passing through the point P is r equals a plus lambda b. A is 2i plus 3j plus k and lambda, and the b is parallel vector, which is parallel vector for this line, but it is normal vector for the plane. So 2i minus j plus 4k. Now 2i plus 2 lambda I. So 2 plus 2 lambda I. Similarly 3j minus lambda j. So 3 minus lambda j, and k plus 4 lambda k, which is here. So now this is a point. This is a general point on this line. So I can consider this point M over here as well. So 2 plus 2 lambda, 3 minus lambda, and 1 plus 4 lambda lie. This is a point on M, but this m lie on the plane, right? This plane. So we have to substitute all these. So twice of 2 lambda, 2 plus 2 lambda minus y, it means minus of 3 minus lambda, 4z and 1 plus 4 lambda. So just calculate, you will get lambda 1 over 3. Just put lambda 1 over 3 back to point m. So you will get 8 over 3, 8 over 3 and 7 over 3. You can see calculation. Now matrix M is given by, okay, fine. Now the matrix M represents a sequence of 2 geometrical transformations. State the type of each transformation and make clear order in which they are applied. So first is this and then second is this. So here we can easily observe. First is 1 0 and 0 1, okay? So 1 0 is here and 0 1 is here. So this is one square. But instead of 1 0 0 1, we have 1 0 and k1. It means 1 0, okay, 1 0, this 1 0 is still here, but this is k1. K1, it means it is shifted somewhere here, okay? So now instead of this square, you will get this kind of shape, and this is called shear. This is called shear. So shear in the x direction, see, you will get to x direction, followed by rotation in anti-clockwise about the origin. Yeah, now this one is, we know that if you are rotating about theta in anti-clockwise sense, then cos theta sin theta minus sin theta cos theta, this is the rotation. But here if you apply 45 degree, then you can get cos 45, which is root 2 over 2. So this is simple, just you need to observe. Okay, now triangle ABC in xy plane is transformed by M onto DEF. Find in terms of K using single matrix which transform DEF onto triangle ABC. So that's simple again, because here when ABC is transformed to DEF by matrix M, then DEF get back to ABC by matrix M inverse. So we need to first find M vector. So M vector is just multiply them. So root 2 over 2 times 1, which is root 2 over 2. Okay, now this times 1 and then this times 0, which I have not written. Now 1 over 2 root 2 times k, which is 1 over root 2 times k, and now minus 1 over 2 times root 2 times 1, which is here. 1 over 2 root 2 times here it is 1. So 1 over root 2 times 1, which is 1 over root 2, and 1 over 2 times root 2 times 0, which I have not written. 1 over 2 root 2 times k, which is here, and 1 over 2 root 2 times 1, which is 1 over 2 root 2. Okay, so you can observe here 1 over 2 root 2 over 2 is common everywhere, so you can take root 2 over 2 outside. Now it is 1. Now here you can check, it's outside, so it's 1. Then here also outside, it's 1. Now this is k minus 1, this is k plus 1. So this is my M. Now M inverse, we know that adjoint of A over determinant of A. So adjoint of A is very simple here. Root 2 over 2 here, just you can swap. So k plus 1 and 1 and change the sign. So minus k plus 1, change the sign, minus 1. And determinant of A, determinant of, sorry, here it should not be A, it should be M. So determinant of M. So how can we find determinant here? Okay, so when you need to find determinant, so suppose you have k times A, B, C, D. This is your matrix, okay, and you need to find determinant. So it will be k square and determinant of A, B, C, D. Okay, so this is root 2 over 2. So root 2 over 2 whole square, and then just find determinant. How will you find? Just multiply. 1 times k plus 1 minus of 1 times k minus 1. K and k cancel, and then what you will get, what you got here, you got in numerator root 2 over 2 divided by root 2 over 2 whole square, and k cancel, 1 times 1 which is 2. When you solve it, you will get 1 over root 2. Okay, now and this part k plus 1 minus 1 minus k plus 1 and 1, you are left with this. So m inverse we got. So find in terms of k. So we got the answer. This should be the answer. Now C part, find the set of values of k for which the transformation represent m has no invariant lines through the origin. Okay, so through the origin the line is y equals mx, and I'm going to consider, this line has been this matrix has been multiplied by other matrix xy, and image is x dash y dash, but we know that x dash y dash and xy should be same for the invariant. Okay, so then just multiply. I took root 2 over 2 here, and then 1 times x and k minus 1 times y. So here now again 1 times x, k plus 1y. So now this is root 2 over 2 is 1 over root 2 basically. So 1 over root 2x, 1 over root 2y k minus 1 equals x dash. 1 over root 2x, 1 over root 2y k plus 1 equals y dash. Okay, now we know that y dash equals y equals mx, and this x dash y dash will satisfy this line also. So y dash equals mx dash. So now y dash, which is this, okay, which I have written here. Now m, which you can see, and x dash I have written from here. Okay, so this is x, and now this is x, and what is written? Oh yeah, this is x, and this y I changed to mx from here. Okay, so x and then y is mx k plus 1, m is outside x, and y is mx k minus 1. Now x I took common from here, then 1, and m times k plus 1, x again I took common, then m times 1 m, and m times m square k minus 1. Now compare the coefficient of x. So x coefficient is 1 times m k plus m, and x coefficient here m plus m square times k minus 1, which is here. So m and m you can cancel. You will get k minus 1 m square. Take mk to right side, which is minus mk or minus km. 1 to right side, minus 1. But here it is clearly given that no invariant line, so you should not get any values of m. So this quadratic equation will not give you any values of m, so d should be less than 0. So minus k whole square minus 4, b square minus 4ac. So minus k whole square minus 4a k minus 1, and c is minus 1. So k square minus 4k plus, oh sorry, this minus times minus 4, which is plus 4. 4 times k and minus 4 less than 0. So you can get first these two roots, and then this is plus minus plus. We have to deal with these values because it is less than 0. So minus 2 root 2 2 minus 2 plus 2 root 2. This should be the value of k. Now show that the curve with the Cartesian equation has polar equation. Okay, so in general we know if it is r and this is theta, then x is r cos theta, y is r sin theta. So just put x and y. So x square plus y square. Oh, we know that x square plus y square, r square, and then cos square theta sine square theta. So only r square, right? So here you will get r square whole square, which you can see, then 36, r square cos square minus r square sine square. So r to the power 4, 36. R square common, cos square minus sine square, 1 r square over r to the power 4 over r square, which is r square. And 36, cos square theta minus sine square theta is cos 2 theta. So here we got the answer. Now curve C has this equation, and angle is minus pi by 4 to pi by 4. Sketch C and state the maximum value of distance of a point C on from the pole. So r square is 36 cos 2 theta. R is, or you can apply root, then you will get 6 root of cos 2 theta. We need to find the coordinates of r comma theta, or theta comma r. So theta is x-axis. Here I have already drawn that graph, but I will erase and I try to explain again. Please try to understand here. This is theta. Theta minus pi by 4 to pi by 4, right? So we need to get some points. So I wrote minus pi by 4, minus pi by 8, minus pi by 16, 0, like that. Okay. And then you have to substitute theta is minus pi by 4 in this. So 6 times root cos twice of minus pi by 4. Use calculator. So you will get 0 and these coordinates. So now what are the coordinates you have? Suppose theta comma r you need to write. So this is minus pi by 4 comma 0, right? Or next is minus pi by 8 comma 5.05, like that. Okay. So when theta is minus pi by 4, okay, we will try to understand from here also. 1 minute. And this angle I'm going to consider maximum is pi by 4. No. Yeah. Okay. When theta is 0, it's not pi. Here I will consider. Here I will consider. When theta is 0, then it is 6. So this is 0 comma 6, 1 point. Okay, first I will use these. When theta is pi by 64, which is very small, pi by 64, but r is 5.99, which is 6, right? Which is almost here. Now pi by 32, but 5.94, it is still 6, right? Around 6. Pi by 18, 5.05, so somewhere here. Pi by 4, when pi by 4, then it is 0. Oh, r is 0, so here. It means your curve should be like that. Okay, now it is symmetrical, or you can follow these. You will get this. Okay, so this will be your curve. That's how you can get. First, let me explain. This is your theta, and this is your r. So what's the maximum distance of a C from the pole? This one, right? This is 6. So this 6 should be the answer. Maximum distance. Okay, find the area of the region. So we know the area of the region 1 over 2 r squared theta a to b. So that's how 1 over 2 r squared theta minus pi by 4 to pi by 4. 1 over 2 r squared is 36 cos 2 theta. So 36 over 2, that's 18. And cos 2 theta integration is sine 2 theta over 2 minus pi by 4 to pi by 4. 18 over 2 is 9. And sine 2 theta, sine 2, and upper limit is pi by 4. So twice of pi by 4, sine twice of pi by 4 minus sine 2 and angle minus pi by 4. This is 1, this is minus 1, but extra minus, so plus 1. Answer is 9 times 2, 18. Find the maximum distance of C from the initial line. Okay, initial line. This will be your initial line, and maximum distance from the initial line. So distance from the initial line can be this or this or this or this or this. It looks maximum or this, right? But how can we get that? So this is y. So y should be maximum, right? We know that y is equal to r sine theta. So r is 6 root cos 2 theta, and then this is sine theta. And for maximum minimum, we know that dy by dx 0. So here it is theta, so dy by d theta should be 0. So here we have to apply product rule. So product rule says u times v dash, which is uv dash plus uv dash. So 6 now cos 2 theta. Let me write this again. So here you can write 6 times cos 2 to the power half times 2 theta. So first you have to differentiate this part, which is this. Keep sine theta as it is, and then you can keep this part as it is and differentiate sine as cos theta. I have written all the steps. All the steps I have written. So you can pause the video and you can understand on your own. Now dy by d theta, I got this here. Now you have to equate to 0. So just equate to 0. You can take 6 common. Cos 2 theta cos theta minus sine 2 theta sine theta. So this is cos A cos B minus sine A sine B. So you can write cos A plus B. So cos 3 theta 0. 3 theta should be plus minus pi by 2. So theta should be plus minus pi by 6. Now y was this. So just put y equals plus pi by 6. Do calculation carefully. You will get 3 over root 2. So this is your y max. Now question 7. That says this is your curve. Find the equation of asymptotes. So for the vertical asymptote, and denominator should be 0. So 5x minus 2 should be 0. X equals 2 over 5. And for oblique asymptotes, okay, when the degree of numerator is 1 greater than degree of denominator, then you should divide first. So 5x squared, when you divide by 5x minus 1, you will get this quotient. Now you can write 5x squared over 5x minus 1 as x plus 2 over 5 plus remainder 4. This is 4 over 5, right? y2 4 over 5 over 5x minus 2. But when x will approach to infinity, this will be 0. You are left with this. So this will be your oblique asymptote. Okay. Now find the coordinates of a stationary point. So here I will apply u over v rule. That says u dash v minus uv dash over v square. So u dash, first we have to differentiate 5x squared, which is 10x. Second as it is, minus 5x squared as it is. 5x differentiation is 5. And denominator whole square. And just calculate. You will get this. dy by dx should be 0. Equate to 0. Now 25x squared minus 20x should be 0. Factorize x equals 0 or x equals 4 over 5. When x is 0, then you can get y also. Put 0 here. So y will be 0. So 0, 0. Or when x is 4 over 5, just put 4 over 5 in this. You will get 8 over 5. Here I did. You can check. So we got 2 stationary points. Now sketch. So first of all, we will sketch asymptotes. So this is x equals 2 over 5, and another asymptote is y equals x plus 2 over 5. And we have 2 points. a stationary point which is 4 over 5 comma 8 over 5, and first another stationary point is 0 0. So these are asymptotes, right? So our curve will about to touch these asymptotes like this and like this, and this is a stationary point. So here it should be smooth, either upward or downward, but downward cannot possible in this region. It should be upward only, then only it can touch this. Here also this is a stationary point, so graph can be downward or upward, but upward is not possible in this case because it has to appear as a touching curve with this asymptote and asymptote, but it will not touch, just it should appear. So this will be your curve. So this black one is basically your curve. Sketch C. Now I sketch the curve with the equation and set. I have already drawn here something, but okay, let me explain this. Mod, right? So mod positive is positive, so this part you can see here. Okay, and what's the maximum value? 8.5. so this is your 8 over 5, sorry. And mod means this down portion will go up. That's why it is going up like this. Okay, so this mod graph we have drawn. Now find an exact form from the set of values of x for which this mod is less than 2. Less than 2. So this I have drawn y equals 2 because this is 8.5, which is smaller than 2, right? So y equals 2 will be there. Then just take point of intersection, one solution. Now here it is intersected, second solution. Now here it is intersected, third solution. Here also it is intersected, 4 solutions. So 4 solutions will be there for mod and 2. So we will find those solutions also. 5x squared over 5x minus 2 equals plus 2 or minus 2 because in the mod. So just calculate this part, you will get these values, and calculate this part, you will get these values, right? But the important point is how will you plot these values. So you need to find some decimal values to understand also. So this is decimal is 1.44, 0.55, here 0.34, here minus 2.3. so least is minus 2.3, which is minus 5 minus 3.5. so this one. Then is 0.34, so which is minus 5 plus 3 root 5 over 5. Then 0.55, 5 minus, this is 5 minus root 5 over 5. And the highest is 1.44, 5 plus root 5 over 5. Now this is smaller than 2, like below, lower curve we need to find. Lower than this line. So lower than this line, this curve is valid, as well as this curve is valid. So for getting this curve, we have to move from here to here, right? And for getting this curve, we have to move from here to here. So our answer should be this region, which is minus 5 minus 3 root 5 over 5 to minus 5 3 root 5 over 5. This one. And this one. 5 minus root 5 over 5 to 5 root 5 over 5, this one. Okay, if you simplify further, you can get that also, it doesn't matter, but these are the regions. Okay, that's it. Okay guys, thank you very much. Then here also I did not teach you anything new. You should know concepts, and here you can just verify your answers, or you can revise this whole, further pure mathematics 1. You can revise quickly. This is just for the revision, it's not for the learning point of view. If you come here, it means you know the concepts, and you just want to know how to do past paper questions, and what will be the procedures and steps while solving, right? So you should already know the concepts while attempting any past paper. Okay guys, I hope you have revised well. Thank you very much. See you in the next video. Bye.